All right, this is task 2, click and clones for the cloning assignments. All right, so it's on a website that unfortunately does not work for you all, so this link will not work. But there's 3 questions you're going to answer. Predict what color the cloned mouse will be, why do you think the mouse will be that color, and what color was the cloned mouse? Were you right? All right. So hopefully this video will walk through the website, help you answer some of the questions on your documents. So let's get started. Click and clone. Using what you know about somatic cell nuclear transfer, let's try it out. Your mission is to create a genetically identical clone of Mimi, a brown female mouse. Click on Mimi to begin. Welcome to Mouse Cloning Lab. Here you'll find all the tools you need to clone Mimi. First of all is Mimi. It's a mouse we will clone. Second is Megdo. She's the egg cell donor. She's a black mouse. Mimi's brown. And Momi is a surrogate mother to grow Mimi clone. She's a white mouse. We'll use a microscope, petri dish, a sharp pipette, a blunt pipette, chemicals to simulate cell division. All right, let's clone Mimi. First, let's examine the steps. The first step will be isolate donor cells from Mimi and Megdo. All right, click and drag a somatic cell from Mimi and an egg cell from Megdo. Place each one on the correct petri dish. So click somatic cell, Megdo, egg cell. Step 2, remove and discard the nucleus from the egg cell. Move the egg cell to the petri dish on the microscope. Move in the blunt pipette. Move in the sharp pipette. And suck out that nucleus. Step 3, transfer the somatic cell nucleus into the enucleated egg cell. So move the egg cell to the nuclear transfer dish, move the somatic cell in. We'll now transfer the nucleus from the somatic cell into the enucleated egg cell. Move this under the microscope. Move in the blunt pipette. Suck it out with the sharp pipette. Then insert the sharp pipette into the enucleated egg cell. Now that you've substituted the egg cell's nucleus with the nucleus from a different type of cell, the new DNA in the egg cell needs some time to adjust with one another. Essentially, the DNA needs to be rebooted or reprogrammed to behave as though it were the DNA of the egg cell. This will take a couple hours. In our case, we'll warp through time to the next step. Step 4, simulate cell division. Now you need to simulate the egg cell to begin cell division, also known as mitosis, in the petri dish. To do this, add a drop of liquid chemical that mimics cellular events that occur when the egg cell is fertilized by a sperm cell in the male mouse. Wait until the cell has divided a few times, creating a ball or a morula of 16 cells in the petri dish. Ding, ding, ding. Do the next step. Next step, implant the embryo into Momi, the surrogate mother. The embryo continues to increase cell numbers and begins to differentiate its cells into various tissue types. The pregnancy takes about 19 days. Step 6, deliver the baby mouse clone of Mimi. So what was your prediction? Was it black, white, or brown? Was it black, brown, or gray? Oh no, black, gray, or brown. So click on Mimi to deliver the baby. We'll see. The mouse is white, brown, or black. Well, since Mimi was brown, I think this one's going to be brown as well. Yes, because the pup's genetic material came from Mimi, she too is a brown mouse. Why don't we call her Mini Mimi? All right. Now you can answer these 3 questions on your documents.